So the last lesson for this unit is honors only. The on-level don't do this, so that gives you an indication of where we're heading. It is a little bit difficult, but we're going to be doing Hess's Law. And so Hess's Law, basically, it kind of states that the change in enthalpy, so that's energy, right? For a reaction, so basically the change in enthalpy is also known as the change, or delta H, right? So there's some fancy talk, but you're about to see this over and over again. Delta H is the enthalpy change. So enthalpy and heat, you can think of them as the same thing, but when you get into more advanced science, they're not the same thing, but as far as we're concerned, that works. So delta H for a reaction is equal to the sum of stepwise reactions. And so this sounds really fancy, but it's not. Basically means that if I have to go to Kroger over there, on 120, and I stop by Panera first, the distance between here and Kroger would be the distance between Hillgrove and Panera plus the distance between Panera and Kroger. Okay, like it ain't that bad. So that's the definition, though. Wanted to at least start with that. This is a puzzle. Like, could I give you steps? Yeah, I could, but it don't work like that. It's kind of like a mix of the matching game and just like logic. Do you know how the matching game works where the cards are folded over? Yeah? So what that ends up looking like is when you find a pair that matches, what do? You can take them out. So what I'm going to show you is when things match from like reactants to product side, I'm going to pull them out and they're not going to be there anymore. They're going to kind of cancel. So if you understand that, I'll just start just straight off. Now, these take a while, so what I'm going to do, and they are really long as far as writing stuff down, so I'm not going to waste my time making you write these down. I'm just going to I'm going straight to your paper. Okay. I think I'll start with, you would think they'd just start with number 1, right? I don't want to start with that one because it's, like 3 halves? Let's start with, I don't know. Number 2 is looking pretty chill. Hopefully I don't regret it. It's fine. I'll make the link on YouTube private. It's not messy, but it's not, it's a puzzle. So here we go. Basically, if you look on all these problems, just take a peek at them. At the top of each question, there's like one reaction by itself. Can you see how at the top there's a reaction all by itself? And then below that, you have like 2 or 3 reactions. So the top reaction, so I'm doing number 2 for you guys, right? That top reaction, this is called your target. So this is like your goal, okay? So what you have to do is you have to play the matching game and rearrange things to get this as your final reaction. And the reason we're doing this is because if we can get all these little steps to work out, then we'll know the energy change to make this was the sum of them, just like us driving to Panera and then driving to Kroger. Okay? Do you kind of get what I'm saying as far as like why we're doing it? Okay, so let's do it. So my goal is going to be, I need 2 carbons. It is important that there's an S here because sometimes like with water, liquid, and then gas, do not cancel. Like that's playing the matching game and one of the guys has got a hat and the other guy don't. Like it's not the same. So the states of matter are important. So I need 2 carbon solids plus 2 waters as a gas. That is important. They don't cancel with liquid. I know I already said it, but I'll say it again. And then I need 1 methane gas, and I hope I don't run out of room because I was, okay, this isn't taking up the room, and that's a gas. All right, now, what you're going to do is, can you kind of look at at the three reactions and kind of see how they have stuff in common. So this first one, it has carbon as a solid. So this is 1. And then it has the water. Notice the water's a gas, so that's good. I'm trying to make this, and these are my pieces, right? So you can see some things in common. Okay, do you see how this carbon monoxide ain't up here? That's going to have to get pulled out at some point. And we can do that by finding something that matches. This is on the product side, so we would need a CO on the reactant side. So I'm already kind of looking at that going, okay, if I keep this one, listen, these reactions they give you don't always use them all. So it's like sometimes you're putting things together like a puzzle, there's like a piece from a different set, and it don't even need to be there. But I can see like, this is looking good, this is looking good, I'm trying to make this, okay? On the second one, I have carbon monoxide. Now, what was I saying about that one? It's going to have to come out, right? So that's very promising to me. Like, I'm seeing how these are good. You don't need to write anything down. This is on your paper. This is too much to write. If you try to write instead of follow me, you're going to be super lost. Like, I did this on purpose. Do not write this down. There's no steps. It don't work like that, okay? I'm talking you through it while you don't write things down so you can hang with me. Don't write anything down. I'm just writing down what's on your paper, but I'm talking you through it as I do it. Anyway, so I got carbon monoxide, and then I had water as a gas. Now listen, look. How many waters do I have? And how many is showing up? That's good. That's what you kind of want to see. And then that gives me carbon. I need to put that carbon dioxide. Be careful with the mono and di and all that. And then H2. Now, these hydrogens, they are not up here at all. Are they they cancel? You know how I told you about them like canceling out? They have to be on opposite sides of the yield sign. These aren't going to cancel. That's problematic, okay? So let's see what's showing up in number 3. In number 3, I have the methane. Okay, now, let me ask you a question. Did you see methane at all anywhere before here? No. And it's a reactant. So if I want to use this, I know 100% I'm going to have to use reaction 3 because it's the only one that has this product. Now, do you see how it's a reactant though? That tells me that this bottom one is going to have to be reversed. So we have to reverse some of these reactions. Okay? It's okay if you don't totally get what I'm saying, but can you kind of see what I'm saying? See how I have to have this as one of my pieces, the methane, and it's on the wrong side. So I can go ahead and tell you, before you even write down the rest, I'm using number 3, it's going to be reversed. And then when I reverse it, notice how I didn't write it down, I should. These little delta H's. I'll do it in a minute for all of them. How about that? So I have methane, and then here's my water as a gas. Oh, I didn't need that parentheses. Sorry. I wish there was like, not a better way, but you know, I'm always like, just draw a chart and everything's fine. Yeah. This is like, hope you're smart. Good luck. No. There's 3 hydrogens. Y'all are smart, but this is not something for the faint of heart. There is a rhyme for you. I'm going to be a rapper one day. Now, I saved this for the end for a reason. The enthalpies, so my delta H here, delta H, delta H, delta H. These numbers are what this is the goal. Yeah, like I need to make this, but the goal is to figure out delta H, because that's what we've been doing this whole time, like heat and stuff, right? So, on that last one, I know, for example, I'm going to have to flip that sucker around. So this number that they gave me, 206.1 kilojoules, when I flip this and make it go in reverse, guess what that's going to become? Just intuitively, what do you think? Negative 206. It ain't, do you see what I'm saying? Like, if it goes in the opposite direction, right? Like, if you think about a number line, if here's 0 and here's 5, if I go that way, I'm increasing by 5. If I go that way, I'm decreasing by 5. So if you reverse something, you got to flip the sign. Are you following me on the concepts here? Okay, so we're still puzzle piecing this out. I didn't write down all the enthalpies yet. The first enthalpy was 131.3 kilojoules, and then this enthalpy enthalpy was negative 41.2 kilojoules. Okay, so like I said, sometimes you don't even need to use all the reactions, but let's just start checking them off. So I know I need 2 carbons, so where do you see carbons anywhere? Reaction, which one?
First reaction.
Do you see it anywhere else? Just carbon as a solid. Be careful about the states of matter. Do you see it anywhere? It can be product or reactant. Do you see carbon anywhere else?
No.
Just reaction 1. What is wrong here? Ain't enough. So right now, I know 100% I need reaction 1 and it must be multiplied by 2. What do you think is about to happen to this enthalpy right here? It will get multiplied by 2. So this sucker, taken care of. Still good? You can, yeah. You can start writing on your paper now because I'm doing the things. So that first reaction, and these will, if you just trust and go with it and do like kind of start checking stuff off, it will come out in the wash. Like everything will and it just comes out perfectly every time. Or at least the ones that the quiz and test do. They're not hard. Like this is harder than the one on the quiz. I think it just has 2 reactions. All right, now do you see how this water is showing up all over the place?
Yes.
I'm not even going to mess with that right now. Don't even. If it's showing up, don't even. That carbon was in one place, so I went ahead and took care of it. But the water, there's always one that's everywhere. Just ignore it. It will work itself out. Okay? Now, the methane. What did I tell you about the methane? Where does it show up?
3.
Only in 3. So, and there's only one of them down there, so that's good. But what do I need to do? I'm going to have to reverse it. Guess what happens? What did I tell you about the enthalpy? What's going to happen to it? So this is going to get reversed, and it's going to be times negative 1. So I have to reverse number 3. Because the methane is a product, but in the reaction 3 it is a reactant. Okay, now, check. The carbon dioxide, does it show up in a bunch of places? Be careful, carbon dioxide, carbon monoxide. Carbon dioxide, how many places does it show up?
1.
I only see 1. CO2. See, you gotta be super careful. Is it just 1, you guys? My handwriting's a mess. This is important, let me not mess this up. So, that means it's a product, right? Let me get a different color. I'm going with my color coding. Here's my carbon monoxide, dioxide. Is it a product? Yes, and there's just 1. So, this one I'm going to keep as is, and I don't have to do anything to it. Multiplying by 1 don't do anything. Now, if you take on your paper, okay, you rewrite this one, multiply all the coefficients by 2. You rewrite this one as is. Make sure you stacking these up. So, see how these yield signs line up? You better write it so it lines up. Okay? And then take on your paper and write this one backwards. That means that you will write down 3 hydrogens plus 1 carbon monoxide gives you 1 CH4 and 1 water. If you will write them, stack them on your paper right above each other. Look, make it reverse. This plus this gives you that and that. Okay. Products become reactants, reactants become products. And then, listen, what's going to happen is you're going to be so pleased with yourself when everything cancels. You're going to forget about the enthalpy, which was the purpose. So as you're doing that, on the first enthalpy, it's going to be 262.4. This one ain't going to change. This one's going to be negative 206. So as you rewrite it, rewrite your enthalpies too. Do that. You can do that by yourself. I will give you a minute. Yeah, you're going to write 3H2 plus CO gives you CH4 and water.
You're not changing sides.
You have to multiply the enthalpy by negative 1. Okay. So the first one times 2. Second one, leave it alone. Third one, flip it over. I got to scroll down because I got to redo this. I'm going to rewrite the target as well. signs. That's kind of a big deal. Still working? Me too. Oh, why did I do that? Just kidding. Alright, and then the last one, we're just writing in reverse. Alright, you should be about done, yeah? Good. Okay. Did you change your enthalpies as you wrote it?
Yep.
So that one times 2, that one stays the same, that one got multiplied by -1.
62 plus 6.
What?
The first one. What, 6?
Oh, okay, yeah. Forgot about that part. Thanks. Okay, so here's where the matching game comes in. Stop what you're doing. Don't try to write this down as I'm doing it. It'll be like a magic trick, and then I'll have to start over. All right. So, one more time. Matching game. How this works is I look for things on both sides of the reaction. So here's, again, the target. I'm just going to draw a line so I don't accidentally mark through stuff. So I'm looking, and I know, like, for example, there was that carbon monoxide that doesn't show up here. The CO, it's not up here. So I know I got to get that to go away. So you cross your fingers, and then you're like, okay. So do you see how there's one carbon monoxide and one carbon dioxide? Do you understand why I started with carbon monoxide? I know it's got to go. Okay, it's got to go away. So there's 1, 2 of those on the reactant side. This is like an imaginary line. Make sure these line up. Now, you see how there's 2 right here? Cool. Gone. 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 Happy times? Just imagining. So if it's on this side, it's on that side. Now, let me tell you something. If there was just 1 carbon monoxide right here, I would have taken away the 2 and made it 1. Like, you can also do like that. Does that make sense? Okay, now what was that other one that doesn't show up there? Hydrogen? Okay, so there's 3 hydrogens. And then over here, I have 1, 2, 3. Again, let's pretend this set of 2. 2 hydrogens. 2 hydrogens go away, left with 1. That's okay. It doesn't have to match exactly. But this one does. So 3 go away. 3 go away. Now, cross your fingers and then see what's going on. Do you see anything else that cancels? Well, okay, I see a water that cancels. Do you see it?
Yes.
Okay, so there's 1 water, there's 1 water. Anything else? From side to side. All right, this is where you just do like this real quick. I got 2 of these, I got 2 of these. 2 waters, two waters. See how I'm checking below myself? It don't matter. If it's over here, that's not the same. It has to be on the right side of the line. One methane, one methane. One carbon dioxide, one carbon dioxide. And I never even talked about that water. And it worked out like I told you it was going to. I didn't even do this morning. I just hope for the best. All right. So, how do you feel about that? Okay. The fraction ones, we do need to do some. Number one, I skipped because it has a fraction in front of the oxygen. Okay. Do you realize that 3/2 is 1.5? So if I have one oxygen plus a half of oxygen, that gives me 3/2. How are you at math? 3/2 is 1.5. Okay. So I'm gonna give you like 2 minutes. Do you know how at the beginning I just started kind of looking and I was like, okay, this is only in one place. This has got to stay. Or, oh, this is only in one place. That one's got to be reversed. Or, oh, I need 2 of those. So this got to be my times 2. I'm going to give you like 2 minutes to do that. I would not recommend that you work it out yet, but I want you to just think about what you would need to do. We're doing number 1 now, okay? I would like you to think about what you're going to have to do to get to rewriting it, number 1. So just kind of plan what you think you might need to do. Yes?
So what do we do with the...
Oh, yeah, I'm not done. Thank you. God bless America. So the final step is thank you. This is what happens. Like you get it, and then you're very happy with yourself, and then you forget to add up your enthalpies. So I like to, just to make sure, I like to rewrite, like I checked it. I'm very confident that mine matches up. So now you add these up. Because that's Hess's law, it says that the enthalpy of the reaction is equal to the stepwise reactions. So now just add those numbers up. And that's the answer. This ain't the answer. This is inconsequential. This is the answer. So 262.6 plus, or excuse me, I guess I should say minus, 41.2 minus, is that 206.1?
Yes.
Right. 206.1. The enthalpy is 42 delta H total equals 42.3 kilojoules. Is this an endothermic or exothermic reaction?
How did you get a 42?
How did you get 42? I was like, I was so happy.
What did you get?
262.
Did I 262.6, right? Minus, oh, I did 14 instead of 41. So what is it? I'm sorry. 15.3? Okay. Hey, let me not write this in yellow because when I print this out, it won't print. Delta H equals 15.3 kilojoules. Now, what I was trying to say before I was corrected on my lack of ability to type numbers in calculators is this endothermic or exothermic? Endothermic. So that's kind of, this is AP skills. This is an AP concept. If you enjoy this, then this is great for AP. If you did not enjoy this, this is what AP is, just over and over and over again on repeat. Just like logic. Alright, do number 2, don't work it all out. Just come up with a plan. I mean, number 1, do number 1, just come up with a plan. Okay. Okay, so I'm looking for, this is what I'm searching for to get. Strontium and carbon gives me 1.5 oxygens and 1 strontium carbonate. Alright, so let me just take a peek. Let's look one at a time. If you have to just take it one thing at a time from the target. So I'm looking at strontium. I see strontium here. Do you see strontium anywhere else? 100%. I'm keeping number 1. Sometimes you don't use the reaction, so don't get spoiled thinking that. But do I need to do anything to it?
No.
I can't do anything to it because it's on the right side and it don't have a coefficient. I'm good. That one's straight. Now, carbon, if I look at carbon, I can see carbon showing up. Also, I mean, it's just one place, right? No? Do you see it somewhere else? Okay, so here's carbon, here's carbon. Do I need to do anything to number 3? Oh, I can. Okay, so 3.5 oxygens. I mean, well, no. 3/2 is 1.5 oxygens. So I see oxygen. I feel like this is a Christmas present, you So what's 1 plus a half?
3 over 2.
3 over 2. Okay, so far so good, right? Okay. And then, I bet this next one's going to suck. What color can I use? Purple? No, I already used purple. I'll use black. So strontium carbonate. So your strontium carbonate is only showing up in one place. Right, in the product. So that means that they're all just going to be 1, and they're going to be written as is. Were y'all sitting here trying to... Okay, so I don't have to rewrite anything. I didn't want to start with that. So do you see how all those worked out? That means that the extra stuff, so for example, there is no carbon dioxide up here. The carbon dioxide should cancel, right? So let's start playing the matching game. See, I have a strontium oxide. Yeah? Strontium oxide. Strontium oxide. Okay, and then the carbon dioxide, there's 1. There's 1. And then everything else, see how I'm like using colors and stuff, everything else, I mean, it needs to stay. It is what it is. I'm done. I add this up, I'm done. Yes.
Oh, wait a minute.
So that's why, I guess I'm glad I didn't start with number 1. That one was pretty chill. I'm going to keep doing it until you get it. So it's negative 1220 kilojoules, right? Yeah, well, I'll do one more. Now listen, I know the ones in the back get a little crazy. I mean, I hate it when teachers give me like the easy ones for examples and then like, good luck with the hard ones. So, I mean, number 8's looking pretty crazy. What do y'all think? Number 3's looking crazy too. I don't think number 3's as bad as you think it is.
All of them are looking crazy.
All of them.
All of them look the same. I'm going to do number 8. Alright, I'll give you until I write it down to see what you got to do. Okay? Are you getting an idea of how you pull stuff out and all that now? Number 9.
Number 9 has a fraction. The fraction is where I draw the line.
Number 9.
You know, y'all are tripping because sulfur S8 only shows up one time and it has a 1/8 in front of it.
Yeah. Never mind. Number 8.
8 it is. Alright, I'm going to write it down. Okay, so hydrochloric acid, let's take a peek. I'm seeing hydrochloric acid. If you have like colored pencils or highlighter or something to get started, it really does help to color code. Like if I didn't have these colored markers, so I see hydrochloric acid here. And anywhere else? No. Okay, so 100%. This one's getting reversed. And it's getting the the coefficients a minute ago when we multiplied them by 2, you can multiply by half. Okay, so what that looks like, hang with me now. What that looks like is this is going to be negative 507, but then divided by 2. Well, yeah, I mean, I guess you can think about it divided by negative 2, but yes. But do you understand that I have to flip it and take half of it? However that works out for you. So I'm thinking times negative half. 100%. Okay. Sodium nitrite is the next one. So I'm looking for sodium nitrite. I see it in the second equation. Is it anywhere else? No, are you sure? So it's here and it's here. So guess what? What has to be done to reaction 2? So same. Negative half, right? And I already told you if it shows up in a bunch of different places, don't worry about it. It'll come out in the wash. It does. Like, there's no magic trick to it. So now I have, that's nitric acid. Nitric acid shows up. I'm seeing it in the last one. Anywhere else? No, nowhere else? So just reaction 4. Now, what's wrong with the coefficient here? It's got a 2 in front of it. So, there's my nitric acid, there's the nitric acid. Again, same thing. So I guess you better know how to multiply by negative half. That means that this will be negative 17. Do you understand? Okay. And then the sodium chloride. Let me take care of that one real quick. Sodium chloride is showing up in the first one. And look, can you see how it's already going to work out? Yeah. So now this is the time in your life. Did we underline anything in the third reaction? No. It's looking like we're going to need it to cancel some stuff out, though. Do you see? So we'll probably keep it and see what happens. I think for AP, sometimes you don't need it, but I think for honors, I hope that the sheet we have, that's the thing. So we'll probably need it. Now, don't freak out. Just basically write 1, 2, and 4 backwards, cut the coefficients in half. And then leave number 3 as it is and rewrite it. And make sure you take care of your math. You got it. Go ahead. You can write stuff backwards and divide by 2. Okay, so like for example, when you write it, see the water doesn't have anything, you're going to put a half in front of it. Do you understand? Okay. So negative half, negative half, negative half. So number 3 is good.
Isn't